In this video we're going to look at properties of limits. Properties of limits. So some of the properties of limits are, for example, addition and subtraction of limits, or the limits of the sum and difference. So let's say supposing we've been given the limit x, let's say, and we're given a function that says f plus g. So for this situation, the limit will be equal to the limit of fx alone plus the limit of gx alone. So you find the limit of fx and you find the limit of gx, then you add them, and that will be your limit. And this is the same for subtraction. If there is subtraction here, fx minus gx, like that. So another property are the product and the quotient. So for multiplying, let's say fx limit of x c plus, times, more multiplying, so times gx, like that. So the limit will be equal to the limit of, as x approaches c, limit of fx times the limit of gx. And if we're dividing, limit c approaches x approaches c, then the limit is equal to fx over gx. So this will be equal to the limit of fx alone over the limit of c fx, like that. And if you've got limits with roots, let's say limit of x approaching c, this p fx. So this will be equal to root of p and the limit of the fx that's under the root. So these are the main properties you need to know about, and once you know this, it's going to be easy to answer the examples. So example 1, based on the first property, based on the sum and difference. So let's say find the limit of x to 1, x to the power 3 plus 4x 2. So find the limit of x to the power 3 plus 4x to the power 2 as x approaches 1. So what we said when adding limits is the limit of x to the power 3 plus the limit of 4x to the power 2. So firstly, the limit of x to the power 3 as x approaches. So I start with positive 1. So as x approaches 1 from the right, so the limit is going to be, so put 1 there, that's going to be 1. It's going to be 1. And limit as x approaches 1 from there. From the right, from the left side, is equal to, so I put 1 there again, which is going to be 1. Then we handle the 4x to the power 2, so the limit of 4x to the power 2 as x approaches 1 is x, as x approaches 1 on the right, so put 1 to the 4 there, mean to the x there, that's 1 to the power 2 is 1, 1 times 4 is 4, equal to 4, and limit as x approaches 1 from the left, again we put 1 there, which is going to give us 4. So we can see that the limit from as x approaches 1 from the right and as x approaches 1 from the left is equal to 1, and 4 has the same, so it's going to be equal to 4. Then looking at this, we add, therefore our limit as x approaches 1 from both sides is 5. So is equal to 5. Let's go to multiplication. So multiplication, try limit of x approaches 1, we got 2x plus 4 times x minus 1. So one of the properties said that we're going to find the limit of x as it approaches 1 for 2x plus 4 times limit of x minus 1 as x approaches 1. So we can see here we bring back the property of addition. We're supposed to find the limit of 2x and then add them. So in this case we got 1 here, so we put 1 there, it's going to be 2x times 1, which is 2, plus 4, it's going to be 6. We can see that from both sides we're putting 1, so it's going to be 6 either way, times we put 1 here, which is going to be 1 minus 1, which is 0. Our limit here is 0 for this one. And we have Now on division, so for division it's going to be limit of x to the power 3 as x approaches 2 over limit of 2x minus 1 as x approaches 2. So 2, so we put the 2 in the x, that's going to give it 2 to the power 3, and do the same, we put 2 there, it's going to give us 2 times 2 minus 1. 2 to the power 3 is 8 over 2 times 2 is 4, 4 minus 1 is 3. And this is the answer. Then we go over to the roots. So the cube root of x minus 1. So remember this one we said this is equal to the limit of x as x approaches -7. So this one has specified, and I said that it only wants the values of x that approach -7 from the left side. So three x minus 1, 33 cube root, this is 1, this is 3. So this is equal to x approaches x minus 1, everything under the root, the cube root, put -7 here, that's going to be -8, put -7 minus 7, it gives us -8, which is equal to -2. Let's evaluate this one. So if you want to try it out, you can pause the video and try it out. So it's 3. You can pause the video and try it out. So what we're going to do here firstly is we're going to put the 3 into it everywhere to find the limits. Well, of course this is first equal to limit of the top part minus 27, everything over limit the bottom part, like that. So we're going to put 3 into x, making this 3 to the power 3 minus 27 over 3 to the power 2 minus 3 minus 6. 3 to the power 3 is 27, 27 minus 27 is 0, over 3 to the power 2 is 9, 6 negative 6, negative 3 minus 6 going to be negative 9, which will be 0 again. So this is undefined. So I did this to show you that not that when you have a complicated or a polynomial function like this, we have to first simplify it. And so simplifying this x to the power 3 minus 27 is going to give us x minus 3 minus 3x squared plus 3x plus 9. So you can try to multiply this, you see, to take us back to the x to the power 3 minus 27. Everything over, we are factorizing this one. So here we're going to have x squared 2x minus 3x. Therefore our x to 3 plus 2 x minus 3, or I could just write the right version, which is going to be x minus 3 x plus 2. So you see that this cancel out, leaving us with x squared plus 3x plus 9 over x plus 2. And then we can now put the 3 there, making it 3 squared plus 3 plus 9 over 3 plus 2 becomes 9 plus 9 over 5, and this is a 5, and this is equal to 27 over 5.